In this lesson, you're going to learn how to factor trinomials. Let's make sure you understand what it means to be a factor. So on the screen, you see two linear binomials, x plus 4 and x minus 7. Technically, these are each factors because they're being multiplied together. I could tell you to simplify them, which would mean to multiply. You would distribute this x to the second one, and you would get x squared minus 7x, and then you would distribute the 4 to get plus 4x minus 28. You would have two inner like terms, which would produce x squared minus 3x minus 28. So on your screen, you see a simplified trinomial. So now what we're going to do is we're going to reverse directions. I'm going to give you the trinomial, and you've got to come up with the factors, working in reverse. So notice some patterns. X squared, how are you going to get that? Well, it's going to be an x and an x. There are going to be the two products that are going to be added together to give you the middle term, and it's going to be the product of the last two that give you this term. I'm going to give you a bunch of tricks to help you factor trinomials, but we're going to look at the simplest case where our leading coefficient is equal to 1. So I say a is equal to 1. So one of the things you always do is make sure your trinomial is in standard form. I get some hints from this right here. If this is a plus, I think, well, the only way I'm going to get a plus here is if I multiply either two negatives or two positives together. So that would be if it's a plus, the factors are going to have the same sign, where if it's a minus my constant, I'm going to have two different signs. So let's do this first one. There's a lot of methods for factoring trinomials. I'm going to show you using a tic-tac-toe board. So here's what I do. I take my trinomial and I break it up. I put the first term here and I put the last term in the middle. And I call the middle term my checking term. The middle term is plus 6x. So you notice I keep the sign with it as well. So what I do is, below this x squared, I'm going to put two things I multiply together that gives me what's up here on the top. So the only way I'm going to get x squared is to multiply x times x. And then I look at positive 5. Well, the only way I'm going to get positive 5, well, I think about the things I multiply together to get that, it's only 1 and 5. Don't use decimals. And since it's positive, it either has to be a positive times a positive or a negative times a negative. And how I know is I look at this one. This one says signs are the same. This one means both are positive. Now I multiply straight across to get x times 1 is 1x and x times 5 is 5x. The only place I add in this tic-tac-toe board is right here on the side. I check to see if this plus this is equal to 6. Since it is, I have my tic-tac-toe board set up in a format that will work. My one factor is this little diagonal, which would be x plus 5, and my other factor is on the other diagonal, x plus 1. This is in factored form. Make sure that you actually write your answer like this as the product of two binomials, because I'll tell you, there's lots of methods. This tic-tac-toe board is just a method. It's not an answer. Outside of this class, somebody may have no idea what you're doing. Let's try another. Again, set up your board. First term, last term goes in the middle, and your checking term is your middle term. So again, notice it's out of order. First, last, and then your middle term is here. Everything is a product. What times what would give me a squared? Only way I'm going to get that is a times a. And then I think about factors of positive 18. Well, since this is positive, I know it's a negative times a negative or positive times a positive. This means the signs are the same. Same as what? I know they both have to be negative. So I'm going to put a negative and a negative here. My factors of 18 are 1 and 18, 2 and 9, 3 and 6. And my hint to you is begin by starting with the two that are closest. And this is why I said use a pencil, because if this doesn't work, we erase the 3 and 6 and we try something else. So let's put 3 here, 6 here. We multiply across. A times negative 3 is negative 3a. A times negative 6 is negative 6a. The only place I add is right here on the right to make sure this plus this equals negative 9a. It does, which is awesome. It works. You guys are not always going to get it on the first try. Be persistent. So one factor is a minus 6. The other is a minus 3. Now, just a side note, how could you be sure you're right? Well, if you would redistribute, you better get what you started with. So I'm going to quickly do that to show you. A times negative 3 would be negative 3a. Then I'd have negative 6a and plus 18. Combine my middle terms, and it works. I got what I started with, but that's just to check to make sure I didn't mess up. Again, this right here is your factored answer. Okay, set up your board. A squared, last term, and your middle term is your checking term, the only place you check. We need factors of a squared. Well, that's going to be a times a. Factors of negative 18. Well, since it's negative, the only way I'm going to get a negative is if I multiply a positive times a negative together. So I'm going to try 1 and 18, 2 and 9, 3 and 6. Okay, so again, I start with the two closest to one another. So 3 is closest to 6. I'm going to put 6 here and 3 here and multiply across now. So a times 6 is positive 6a. A times negative 3 is negative 3a. Now I check. Does that add to negative 3a? No, that adds to positive 3a. So what's that tell me? Well, that tells me I'm super close. I've got the right number, but the wrong sign. So all I do is go back to this point right here and switch which one's positive and negative. So I'm going to grab my eraser tool, switch this one to a negative, this one to a negative, and this one to the positive, which would produce negative 3a. So now I've got it. So one factor is a plus 3. The other is a minus 6. Okay, number 4. First of all, check and make sure it's in standard form. It is, but I'm actually missing a term, right? This would be my first term, and this would be my last term. I'm missing the one with the x in the middle. So that means that coefficient there would be 0x. Doesn't exist. So first term goes here, last term goes here, and it's got to add to 0 since the middle term is missing. Factors of x squared, easy peasy, x times x. Factors of 144, well, there's a lot, but if you think about it, one that pops to mind is 12 times 12. If I want one to be positive and the other to be negative, I'm going to make one a plus and one a minus. And the reason I didn't look for any more is I know they got to add to 0, so they got to be opposites of one another. It's going to have to be the same number. So even though 2 goes into it, 4 goes into it, 6 goes into it, a lot of things, I'm only trying 12. So I multiply across, that's 12x. Bottom one's negative 12x, and lo and behold, it adds to 0. So my one factor is x minus 12. My other one is x plus 12. There we go, it's factored. Okay, on this next one, check and make sure it's in standard form. It goes quadratic, linear, constant, so I'm good. If it wouldn't be in standard form, make sure you reorder it. Go ahead and set up your tic-tac-toe board. First term, last term, middle term is my checking. Y times y, factors of 7 are going to be 1 times 7. And I need this to be positive, so that means my signs are the same as what? They both need to be the same as this one, negative. So I'm going to do negative 1 times negative 7, multiply across. I get negative 1y, negative 7y, and that does not add to 6. Well, there are no other factors of 7, and I couldn't switch it to a positive times a positive because then I would get positive 8y, and that doesn't work. So this one can't be factored. It's prime, okay? It can't be any further factor than what it is, so you would just say it is just this trinomial here. Okay, let's see if you can figure out this one on your own. Set up your tic-tac-toe board, hit play when you're ready to check your answer. Okay, hopefully your setup looks like this. And then factors of x squared, x and x. Negative 25 means one's a positive and one's a negative. 5 times 5 is 25. I know it has to be the same number so that when it adds, I get 0 in the middle. So my two factors are x plus 5 times the quantity of x minus 5. Once in a while, students will ask, does it matter which binomial I write first? The answer to that is no, because multiplication is commutative. You can change the order in which you multiply and you get the same answer. Okay, number 8. Again, if you don't need my help, go ahead and hit play, or pause rather, and see if you can do it without me. If you need a little more assistance, keep watching. Try to do more and more on your own. Factors of d squared, d and d. Factors of negative 6 means one is a positive and the other is a negative. Factors would be 1 times 6 and 2 times 3. I start with the two closest together, the 2 and 3. Multiply across, and immediately, yes, I got it. Adds to negative 1. And honestly, I was actually trying to mess that one up, so you would see that it doesn't always work on the first try. But if you follow my tips, a lot of times you will get it on the first try. So here are my two factors, d minus 3 times the quantity of d plus 2. Okay, number 9, again, set it up. Y squared. Last term, middle term is your checking term. Factors of y squared would be y times y. A negative means I have to have different signs. My factors of 24 are 1 and 24, 2 and 12, 3 and 8, 4 and 6. I start with my two closest together, the 4 and the 6. So I'm going to put 6 and 4. I multiply across, that's 6y, negative 4y, and that adds to 2y. Okay, even if I switch the signs, not going to work. So I'm going to back up and do a little erasing. I'm going to try the next two, 3 and 8. All right, multiply across, 3y, negative 8y. 3y plus negative 8y would be negative 5y. Doesn't work. Cross this one off. So here's finally an example where we're going to try a couple of things. So let's go to 2 and 12. So I'm going to put 2 and 12. Multiply across gives me 2y and negative 12y. I add and I get negative 10y. Well, that tells me I'm close. I got the right number but the wrong sign. So if I switch it and make this negative, in other words, this one here the negative and this one down here the positive, make sure everything still works. Positive 12 times negative 2 is still negative 24. This plus this is now positive 10. So I have my factors. One is on this diagonal, y plus 12, and the other is on this diagonal here, y minus 2. Now, just a note, once in a while students say to me, hey, couldn't I go straight across? Isn't y minus 2 still one of the factors and y plus 12 if I go straight across? Well, I have to caution you that maybe for this particular example it works, but we will be looking at ones where our leading coefficient isn't 1. So in order to get it to work, you've got to go on the diagonal. All right, now an application question. A rectangle has an area of x squared minus 11x plus 18 square units. Determine the length and the width. So, in other words, what two things can I multiply together to get the length and the width? So it's really just telling you in a disguised format that you need to factor this trinomial. They're just not going to always come out and say it. So set up your board. X times x gives me x squared. Because I have positive 18, that means the signs are the same, either negative times a negative or positive times a positive. Since this is a negative, I know the only thing that will work is a negative times a negative. Factors of 18, 1 and 18, 2 and 9, 3 and 6. Starting with 3 and 6 because they're closest together. Nope, that's not going to work. That adds to negative 9, so I'm going to erase and try the next two. I'm going to try 2 and 9. 2 and 9, multiply across is negative 2x, negative 9x. Yay, that adds to negative 11x. So one factor is x minus 9, so maybe that's the length, and the width would be the other one, x minus 2. Now, does it matter which one you call length and which one you call width? No, it really doesn't. Because if you turn a rectangle, what you called the length will switch to the width. The reasons why we need to be able to be quick at factoring will become clearer as we move through higher courses. This skill never goes away in algebraic reasoning, so it's super important that you understand it and can get really quick at it. So reach out with questions, and you need to practice.